So this is Geometry Semester 2. It's a unit called Similarity Review, number 13. And it's lesson number 2, SAS, which is side, angle, side, SSS, which is side, 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 AA, which is angle, angle, similarity postulate practice. So dealing with similarity. And it's a review. We did similarity in the first semester of the year, and now we're reviewing it here at the end of the second because it's on a lot of the assessments and things that we take, and it's one of the core topics of geometry. So this is on creatormath.com under the geometry tab. You might have to Google creatormath.weebly.com to find the website. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So I'm going to review how to find the notes. It's a little bit tricky. You got to go to the website. There we go. Took me a second. So this is the website name, creatormath.weebly.com. Type that into Google. You should find this homepage. Funny, it looks like I've lost my internet connection. Let's turn this off and see what happens. There we go. Okay, so that updated it. So here's what the homepage looks like. If you have any questions about the composition book, which is another sort of complex part of this course, then scroll down, look for the words composition book. Follow all the directions, watch all the videos, stick to the deadlines, put things where it says to put them, and go and take the notes. We're going to go to Geometry tab where the notes are for this video. Is it my phone? Okay, there we go. Well, it's giving me some trouble today. All right, so we got it. So under geometry, you'll see the vocabulary. Here's the vocabulary practice study PDF. Every vocabulary word we use for geometry for the whole school year is on there, and it's searchable. Download this to your device. If you're not getting 100% on your vocabulary practices, then you may not know how to download this and search it. Google, how do I search a PDF? Using the device you're using, it's slightly different for different devices. Now we're going to find the semester we're interested in for this video. It's this one. Here are the table of contents. You should have copied every line of this table of contents into pages 2 through 6 of your composition book. If you haven't already, please stop what you're doing now and do it. We're going to scroll down to the unit. So each one of these is a unit, and then there's lessons within it. So this one is Similarity Review. Here's the unit, and there's 1, 2, 3 lessons. It's just a review, so only 3 lessons. We're on number 2 right here. So side, 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 similarity postulate, angle, angle, similarity postulate, and SAS, similarity postulate. Here are the pages where these notes go in your comp book. Please don't use this video to tell you what pages. Look at the table of contents at the time you're viewing it. These page numbers probably will have changed. Now the problem set we're doing is this one. The notes go here. I don't have those up yet, and the video solution will be here. Just as a note, since similarity is already covered, right, we're going to go and just glance at similarity from the prior semester. So here's things like side, 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 angle, angle, and how about SAS right there. So if we just glance at these notes, this will be a lot like the way you pull them up for the one once they get put up. They probably will be by the time you get there. So they'll look like either written notes or they'll be pictures of the board. Here's side, side, side similarity postulate. We're going to review that. Here's 3 examples. Here's side, angle, side. There we go. And actually I did side, angle, side. Now I'm doing side, side, side. All right, so it'll be something like this. It'll be just a combination of these because it's a review. And angle, angle, here's the notes. So you'll get these notes for the one we're on, and they'll be uploaded by then, and you'll put these into your comp book on the proper pages, angle, angle. All right, so let's go ahead and proceed with the problems, and then we'll review some of these topics as we go. What does congruent mean? Congruent means same shape, same size. So if we've got two shapes, we want to know they're the exact same shape, and we want to know they're the exact same side. Why do we use congruent instead of equal? I would say equality is a singular dimension, right? 3 is equal to 3 is one dimension. There's only one aspect of this for equality. But for a shape, we need to know if the corresponding angles are all equal, and we need to know if the corresponding sides are equal. So I would say it's multiple aspects of equality. So our, equal corresponding angles and equal corresponding side lengths. Because you have multiple aspects, we have a new word, congruent. Right? So that's what we use in geometry to mean same shape, same size, same exact shape, same exact size. So what does proportional mean? Proportional means larger or smaller by a scale factor, also called similar. And we always break out one of our models here, a scale model, to show you if this is a model helicopter, right? Then this thing is going to be like the original, but it's going to be different from the original. It's going to be the exact same shape as the original, just a different size related by a scale factor. And look, you can see the word scale factor right through the window of the helicopter. I'd like to say I did that on purpose, but I didn't. So that's what similarity is in geometry. Similarity means proportional, or a scale model is a perfect example of that. So now we're looking at what is the symbol for congruence. Congruence is an equals with a squiggly over it. Congruent means same shape, same size. What is it for similarity? It is a squiggly. Similarity means exact same shape, but different size related by a scale factor, or proportional. So let's get into the review. What are the? It says, are the following shapes similar? If so, why? And remember, they're going to draw them in a way that tricks us. So we can't go by the drawing. We have to go by the dimensions. So first things first, let's rotate this triangle around. So see how this larger hypotenuse is now on the bottom. That would put this side here. Right? And if we rotated this around, this would be E up here, this would be D down here, and F would come over here. That would be like this. So E, it looks like it's got double tick marks. DE right here is 50. And EF here is 40. So now we're looking at matching up sides. All right, so what did we have to multiply the 10 by to get 50? Well, looks like 5 times, right? So that would be our scale factor going from this direction to this direction. If we went from this direction back, it would be 1/5. Scale factors depend on the direction we're going. Small to big is a multiplier. Big to small has to be a divisor. So then we match up the 8 with the 40. Is that 5x also? 5 times 8 is 40, so yes, that's 5x also. So we have the same scale factor on the two sides, and the angle between, this is 2 tick marks, and this is 2 tick marks. That means those angles are equal. This is called a side-angle-side similarity postulate. So we're going to circle this one. It says yes, they are similar. Triangle ABC, this one is similar, that's the symbol, to triangle DEF because of side-angle-side SAS similarity postulate. So once we identify those aspects of this SAS similarity postulate, we can now conclude that in fact they are similar, which means proportional. One is smaller than the other by a scale factor. All right, now, given the following are similar, so now they're giving us the same one, right? Giving us the two same shapes with the same dimensions and the same, we know they're similar already. What's the scale factor going from ABC to DEF? This is ABC, this one's DEF, so we're going in this direction. We said it was 5x. That's our scale factor, 5. 5x means 5 times to me. Okay, so I said 5x, but it's times 5. It is given that the following two shapes are similar. What's the scale factor going from triangle DEF to triangle ABC? Now we're starting here at the larger one, and we're going back to the smaller one. What did we have to do to the 40 to get back to 8? We have to divide it by 5. What did we have to do to the 50 to get back to 10? We have to divide it by 5. Or another way to say divide by 5 is to multiply by 1/5, right? That is what dividing by 5 is. We multiply by 1/5. So the scale factor here is 1/5 the scale. And just to give you a notification on these helicopters right here, right? Go back to our scale model. This one, for example, is a 1/43 scale. That means this is the smaller one. If you were to go small to big, you'd have to multiply every dimension on this one by 43. Going from the big to small, it's 1/43. Going from the small to big, it's 43 times. All right, are these shapes similar? If so, why? So I see right off the bat we have all three sides of both triangles. So let's rotate this again down around. They make us rotate it each time. The D goes here, the E goes here, and the F goes over to here. The DE is 20. The FE is 40. And the FD, this hypotenuse, longest side, is 48. So let's match up sides. It's going 5 to 20. So we had to multiply that by 4 times, right? 4x, or 4 times. We're going from 10 to 40, so that's times 4. Check. 12 to 48 is times 4. Check. So because each of the sides, because each of the corresponding location sides is being multiplied by 4 in this second triangle, we can say that this is a side-side-side similarity postulate. Proves that these two are similar or proportional. So we're going to say yes, they are proportional. Triangle ABC is similar to triangle DEF because of side-side-side SSS similarity postulate. Right? Now let's keep in mind this multiple of 4x, because I think they're going to ask us what's the scale factor going in this direction. Then they're going to ask us what's the scale factor going back, which would be 1/4. So if that's true, then we already have 2 more problems answered in this exercise. So given the following shapes are similar, what's the scale factor from ABC to DEF? So sure enough, we're going this way. We said it was 4 times, so it's 4. Now they're asking, let's say we're going backwards. We're going from DEF to ABC. What is the scale factor? So now we're going this way. Well, if we went 4 times that way, we have to go 1/4 to go back. Okay, so scale factor is directional. We have to know which direction we're going in to identify the proper scale factor. Are the following shapes similar? If so, why? So let's try this again. Let's rotate. The hypotenuse now comes down here. We want the same orientation, and this one upside down just makes it confusing. So if this rotates around, this is going to be E. No. This is going to be E up here. The D is going to come here, and the F is going to go over to here. There we go. Sometimes you have to, you can even rotate the paper, right? If I rotate the paper, now I could see that the D's down here in the lower left and the E's at the top. And so now go back. The D's down here at the lower left and the E's up on top, right? So just give yourself a break. Rotate the whole piece of paper and see how it looks, right? I can't always do it in my mind. I need to see it a little bit clearer. Now, this D has 1 tick mark. E has 2 tick marks, right? So 1 tick mark, corresponding location, so same location but different shapes. These match up, and they're 1 tick mark, they're equal. 2 tick marks, this one's equal to this one. So what we know is that if 2 of these are equal to 2 of these angles and their corresponding locations, we know that this third one must match up with this third one, because you would take 180, subtract these 2, whatever they are, and we're going to get this one, and they're going to be equal because those are equal to this one's equal to this one. Okay, so this one's called AA similarity postulate. So yes, they are similar, yes, because triangle ABC is similar to triangle DEF because of angle, AA similarity postulate. Now, I think they're going to, they can't ask us what the scale factor is. We don't know, you guys. There's going to be no. If they ask us that, it's going to be we don't know. Let's see if they do. It is given that the following 2 shapes are similar. What's the scale factor going from ABC? So these are the exact 2. We're going in this direction, but we have no side links to determine scale factor. Remember, the angles are equal measure, and that just means that these 2 are the exact same shape, but are different sizes depending on the scale factor. We would need to know 2 corresponding side links to figure out what the scale factor was. We don't have it, so there's not enough information to tell. Right? We know they're similar, but we don't know by what scale factor they're related in either direction. So now if they're asking us DEF back to ABC in this direction, we don't know either. We have no way of telling. All right, now, that's a pretty good review. Not perfect, but pretty good. So make sure you're matching up the title of this video. Geometry Semester 2, it's Similarity Review, 13th unit, and it's the second lesson, SAS, SSS, AA, Similarity Postulate Practice. It's on creatormath.com under the Geometry tab. You need to match up the title of this video with the practice problems you're doing, otherwise it's not going to make much sense to you, okay? So hope that helps.